Hello my dear friends, welcome to the YouTube channel Math Skill. In this session, let's try to discuss about the chapter Introduction to Trigonometry, and the numerical what we're going to solve is if x is equal to p tan theta plus q secant theta and y is equal to p secant theta plus q tan theta, prove that x square minus y square is equal to q square minus p square. In order to solve this, let us note down the given numerical, that is if x is equal to p tan theta plus q secant theta and y is equal to p secant theta plus q tan theta, then prove that x square minus y square is equal to q square minus p square. Let's note down the given condition for x and y, that is x is equal to p tan theta plus q secant theta, also y is equal to p secant theta plus q tan theta. Now, since we have to find the value of x square minus y square and we have x and y here, let us square on both sides for both the equations, that is squaring both the equations. First, let us try to square the first equation, that is upon squaring we would get x square is equal to p tan theta plus q secant theta p tan theta plus q secant theta whole square. Now this looks like a plus b whole square, that is we know that a plus b whole square is equal to a square plus b square plus 2ab, that is in formula wherever we have a, here in the numerical we have p tan theta, and also wherever there is b we have q secant theta, that is a is equal to p tan theta and b is equal to q secant theta. Now let us apply the formula here in the problem, that is x square is equal to p square tan square theta plus q square secant square theta plus 2pq tan theta secant theta. Similarly, let us square the second equation, that is y is equal to p secant theta plus q tan theta. On squaring both LHS and also RHS, we get y square is equal to p secant theta plus q tan theta whole square. Now this also looks like a plus b whole square. Applying the same formula again. So here wherever there is a in the formula, we have p secant theta, and wherever there is b we have q tan theta. Now let us note down the value of a as p secant theta and value of b as q tan theta. Upon application of formula, we see that y square is equal to p square secant square theta plus q square tan square theta plus 2pq secant theta tan theta. Now in order to prove x square minus y square is equal to q square minus p square, now the conditions for x square and y square what we have got here, these have to be subtracted. For that, let's call this equations as equation 1 and equation 2. In order to get x square minus y square, let us subtract equation 2 from equation 1, that is subtracting equation 2 from equation 1. So we get x square minus y square on LHS. For x square we have 3 terms and for y square we have 3 terms. Let us take all the 3 terms in common brackets minus one more set of 3 terms in one more common brackets. Now upon opening brackets, the first set of terms, that is p square plus p square tan square theta plus q square secant square theta plus 2pq tan theta secant theta would remain as it is because nothing is getting multiplied, whereas for the second set of terms we would see that it is getting multiplied by minus sign, that is minus 1. So the signs of the all 3 terms in second bracket would get changed, that is p square tan square theta plus q square tan secant square theta plus 2pq tan theta secant theta would remain as it is minus p square secant square theta also minus multiplied by second term, that is minus q square tan square theta, minus into plus is minus again minus 2pq secant theta tan theta. That is what we have got here. Now we see that plus 2pq tan theta secant theta and also minus 2pq secant theta tan theta would get cancelled in the next step. That is, these two terms would get cancelled. Now we have p square tan square theta minus p square secant square theta. Similarly, plus q square secant square theta minus q square tan square theta. Let us take p square common out of the two terms. That is, upon taking common, so we would be left with p square into tan square minus secant square theta minus q square. If it is taken common, then we would get tan square theta minus secant square theta. Now we see that tan square theta minus secant square theta here in the first bracket and tan square theta minus secant square theta here in the second bracket are common factors between both the terms. Now let us take common of tan square theta minus secant square theta. Upon taking common, we would be left with p square from first term minus q square from second term. Also we know that 1 plus tan square theta is equal to secant square theta. We have tan square theta minus secant square theta. That is, let us transpose plus secant square theta towards LHS, it would become minus secant square theta, and 1 upon transpose to RHS, it would become minus 1. That is, we have tan square theta minus secant square theta. That is what is required here. Now for that, let us make a substitution. Upon making substitution, x square minus y square in LHS would remain as it is. Instead of tan square theta minus secant square theta, let's substitute by minus 1. That is minus 1 into p square minus q square as it is. Upon opening brackets, in the RHS, minus 1 multiplied by p square would be minus p square, and minus into minus is plus q square. That is, q square minus p square is what we are getting. That is what is to be proved. That is, x square minus y square is equal to q square minus p square. Hence the proof is done. This completes the solution. Thanks for watching the video. Take care.